I recently published this article about the Supermicro SuperServer 65 watt 12 core versus the 45 watt 8 core. So these two systems are similar in many ways, but this article highlights some of the physical differences, and it's about the fan speed and type. So there's the original fan, the 1541, and there's on the 1567. 8 core, 12 core. 8 core, 12 core. So obviously it grew taller, and the fan is wider, 60 instead of 50. Specs wise, it also spins slower at higher decibels though. But when you look at the vanes there, you can see how a lot more, there could be more CFM, more cubic feet per minute. So, all right, what does this actually mean? Well, let's find out. I'm going to dive in to this rig. This is what we got here. Although I've taken these two cords and moved them to UPSs, and that'll let me show you, rather than this kilowatt here, which you can't see, I'm going to have a live readout of watt burn using consumery software by CyberPower. But it's free, and interesting that both machines are using 36 watts now at idle. So we'll start with that. How does Task Manager look on the two machines here? Let's make that big. Sorry, a lot of clutter going on. There we go. All right, so 4 times 4, 16. So 8 cores or 16 threads of execution, logical processors right there. And over here, okay, 4 times 6, 24. So it's a third more level 1 cache, third more level 2 cache, third more level 3 cache. All that makes sense. Scaling linearly, so it should be. Gigahertz similar. These are very relaxed state these machines are in, doing pretty darn close to nothing. All right, so what's running in the machine? This local web server called SuperDoctor 5, just a Supermicro utility that lets me see everything except for the watts of the power supply. So it lets me see the fans, and the nice thing is I don't have to hit refresh over and over. It also lets me show temperatures and so forth on this video. All right, so we have 6700 versus 5100. Now up here we've got Ipmi showing, and this is the back door. This is another browser on my local machine, not the remote servers in the lab here, but the local machine, pointing to the Ipmi or BMC, the IP address of the management interface of each server. So on the left we obviously have the 1541, on the right the 1567. If we go into maintenance, if we go into configuration, fan mode, they're set to full speed. I'm going to put them on standard speed, which is the factory default and what most people are likely to use in their home if it's anywhere near people, because it's noisier when the fans are cranked up like that. All right, so now we should have an instantaneous readout of a new RPM value here, and it's pretty small. It's like 2900. Okay, I'm going to have to zoom in a bit, I guess. If I go to 100, we're going to cut off a whole row of things. That's a little rough, but that is 2900. Whoops. So, sorry. There we go. I was trying to avoid using the mouse wheel, but I might do that. 2600, 2900. So you get a better idea of the fan speeds now. I guess temperature, I'm going to have to pick a compromise. So just a second while I set this up. Instead of 75, let's use 80. Maybe then we can get the best of both. Yep, get the temperatures in. And if we scroll down a little bit, we can see the labels on the system. So 80 it is. What am I about to do? I'm about to abuse the CPUs with Prime 95. So it does a good job at abusing the CPUs and ramping up the temperatures very quickly. Okay, so now we have a difference of 30 watts versus 30 watts again. Settle down. All right. What's this Prime? Actually, I think I have a utilities folder. I'm going to have to grab that. All right. Now this is kind of a one-off build. You're looking at Windows Server Data Center Evaluation Edition for 180 days. So this is not any kind of template, just kind of a one-off effort. And I'm about to be doing some travel. So I'm just trying to quickly sneak in a test before I obliterate the file systems and put VMware on there for some demo coming up soon. All right, so now I've launched Prime 95. I don't really need any other windows other than Prime 95, which I'm about to launch on both, and then we'll watch the temperatures and the watt burn go up immediately as I do that. Now I've noticed in place versus blend, I don't get much difference in watt burn, and you get a little more balanced approach of using multiple subsystems with the default one. So I'm just going to click OK, and then minimize this. You can see all the workers, 16 versus 24 workers. Excellent. Now what do we got? We open this up, we can see the CPUs are cranked right up. The gigahertz also cranked right up. We're not getting, let's see, 2.1 versus 2.7 for turbo boost. Well, it's interesting. This one's 208 and 219. Either way, when it's under maximum stress like this, this is what you get. Similar number of handles and threads. These machines were rebooted about the same time, 3 or 4 hours ago. And there's our temperatures climbing up. All right. If we scroll down, we can also look at DIMMs to get you a baseline there. So I put 4 DIMMs in each. So that way we have fully loaded systems with only one NVMe M.2 SSD laying down flat on the motherboard. We're not really doing a disk benchmark right now. We just want to see the thermal characteristics of these two systems, since Supermicro obviously changed the fan design, as I mentioned earlier. On the left, 4,200 RPMs. Presumably louder. I'll have to measure that with a watt meter at a later date. 3,300 here. So definitely a difference in fan speed there. And we're talking about the CPU fan. So that bigger fan is spinning slower, but probably moving a similar amount of air. So it would seem they tuned IPMI between these two machines probably differently, since we're talking about a different PWM-controlled 4-pin CPU fan on the two systems. All right. So we are hotter on the right. So now you know why when you jam 12 cores in, well, it's doing a lot more work because the gigahertz didn't drop. So they kept the numbers right up, meaning the gigahertz are the same despite a third increase in core count. All right. There's actually a little more to show you here. Get that on the screen. The thing I want to show you is a comparison chart. So while that's running and the CPUs are heating up a little, we got 71 Fahrenheit. Sorry, Celsius, excuse me, 159 Fahrenheit, 145. All right, so we keep letting that rise. I'm going to bring up another browser window, just show you something here. Boy, I did a botched job of typing that. Here's all you got to type. So type that in, hit enter, you get my comparison table here. And this is handy because it really gives you a sense of all of the CPUs in the Xeon D family for what Supermicro makes, including some pricing, which I'll need to update because DIMMs have gone up a little bit in price. And here's the key, decibels and watt burn, right? So this was measured a few months ago on a slightly older BIOS, I'll admit. BIOS 1.1 C is now out. Okay, so here's the watt burn. So this column is the one I want to look at, and 57 watts, 90 watts is what Prime 95 got it up to back then. So let's see how we're doing today. Is 90 watts what we're seeing? The answer is yes. So we've replicated the results. We move from Technical Preview 5, which is basically beta of Server 2016, all the way to the GA version. And a later BIOS, but it doesn't matter. All that boiled down to we're still burning 90 watts when at maximum Prime 95 abuse loads. Okay, and we're getting a nice look at the difference between the two systems. Obviously, on the right, we now have more cores burning more watts, but not 33% more watts, right? That's the nice thing is. So yeah, we're taking an 18 watt hit here. All right. How about temperature? How are we doing? Okay, so it seems the CPU is stabilized. This is about the worst abuse you could imagine. More so than if I do a 4K video, although I want to show that off. Take a 4K video and let it run for hours in Camtasia. That could be an interesting test too. I did some of that and posted some screenshots, basically. Similar to Prime 95, it hits all the CPU cores. Naturally, a job like that, though, that takes maybe 2 hours to render it can take hours to render a 70-minute test 4K video. Well, it would be interesting to see the completion time on the left versus completion time on the right. If it scales linearly, right? Can I get that much more work done? Video rendering might not be your typical thing you'd think of, but you can do those in VMs. You can do that kind of work on VM. You don't have to have a GPU. It can be just a software task. All right. So I think I've run this long enough. These numbers are stable. 72 and 64 haven't changed for Celsius. DIMMs, let's see how they are. You'd have to go back in the video to see if they significantly changed. But I think we're doing a good job at keeping the system cool here. I could point out over here, you also have sensor readings, IPMI, that should match. Should match everything we're seeing. And there it is. Just not quite as pretty as this SuperDoctor 5. But again, you don't need SuperDoctor 5. Say if you're under VMware, you could just run IPMI and see everything. VMware also shows temperature and real-time thermals and fan speeds anyway through its UI as well. So you have many ways to get to this data. 4800, 1100. Okay, so there's still quite a gap in the RPMs. So that bigger fan continues to run slower. Should have a little less CPU fan noise at that point. So if we go to this article about CPU and chassis fan replacements, ultimately this 3D printing project failed. I tried many different fans. I looked at the thermal characteristics. I looked at the temperatures. All of them were at least 5, maybe 8 Celsius higher than the factory stock fan, even this crazy thing with a huge fan, ducted. So I, in the end, don't recommend trying aftermarket fans. And I went with the G-Lid brand here in the CPU. Quieted it down a little, but I was also able to put a new fan in the chassis in the back. But again, all those efforts and the cost really didn't make that big a difference after all this experimentation. So you probably have a better hit on your overall noise by replacing the chassis fan with one of these, if you really want to do the fans. Okay. The thing is, now that they have a bigger assembly, and I'm trying to get the new part number here listed. So when I say there's a new part number, I'm talking about this assembly here. This 0578, that's easy to get. 092A4L isn't found anywhere yet. And that will come with both the fan, the heatsink in the bottom, and the fan attached on the top, and a bracket that goes under the motherboard. It's an entire kit to install. I just want to point that out. I don't think the risk of surgery or stripping screws or any of that is, or dealing with thermal paste, which you'd be doing, of course, if you pull this off. I really don't think it's worth it, especially since the system is quiet. And now turns out the 12-core system is likely going to read quieter than the 8-core at a cost, admittedly. There's a difference in price. But I'm pretty pleased with the mini-core design, by far quieter than any 1U that Supermicro makes for variants of the Xeon D. So I think I've said everything I wanted to say there. Hitting refresh here in this browser, you have to do manually. This UI down here, you don't. It refreshes as you go. And it's still showing stability there. CPU is no longer climbing in temperature. And DIMMs, same deal, maybe slightly. Okay, we got past 60 Celsius in some of these. It looks like the one that's probably outboard or not near the middle of the motherboard is staying the coolest. Actually staying a little cooler in the system on the right. Same thing with 10G, staying a little cooler. Is it significant? I don't know. Cable routing, some stuff could affect that a little, but I doubt it. They're pretty much identical systems. You saw me unboxing in my unboxing video and assembling. And really it's just the CPU and core count that changed and the cache levels, but the motherboard design looks the same. Okay, so that's it for this somewhat messy, a little bit rough around the edges video. I'm probably just going to publish it as is in the interest of time. And there'll be more to come, especially the sound decibel readings check that you'll most likely be pretty interested in. I know I am. But I think this video, again, already gives you a pretty good peek at what to expect as far as watt burn differences. And let's go back to here. I think I should wrap up by exiting prime 95. Okay, and that will help you see how quickly the CPUs cool off. 55, whoops, didn't show this one, 471. Let's see what we get. Watt burn went down, 36 watts on the right, 36 watts on the left. So interesting, we're getting the same watt burn again. CPU temp just dropped dramatically, 54 on the right, 49. So you can see after doing an abusive run, temperatures return quite quickly, even without the fan speed or the chassis kind of profile set to very loud. We're, remember, at factory default fan speed here, and things are looking pretty normal. I did just think of one more thing that I really should show. There's always one more thing, and that would be fan mode. What are the new RPM levels? So we go to full tilt, speeds, okay, that's done. Okay, reduce clutter a little bit. So we got the fans cranked. Great. Now what? Well, we probably want to run prime again. Because even though the fan goes to 6700, I want to see when prime's running, is that the number? Does it even go higher? So 6700, did that change at all? Let's do the same on the right. Okay, so the abuse is happening on both sides. We jump right back to 108 watts. Fan, 5100, 1700, 6700, 1700. So fan 3 is a slight difference of 100 RPM now. And if we wait a little bit longer, go down a notch, you can see CPU temp. It's taking a little while to climb, but it also takes a little while for the web UI to refresh. It's going to wait, and it's going to jump up, as we've seen before in the previous runs. We've actually made it to 114 watts on the right. Not quite sure why. That's more than the 108 we were stable at before. Oh, well, the fan's higher. It looks like it kind of jumps. The UPS battery isn't very granular down to 1 watt. It'll do that jump in increments. So it seems to be toggling between 108 and 114, oscillating. Not really seeing the temperatures go up as much as I thought. So that means the high RPM is keeping things way below the 70. Okay. Well, I really wanted to show you what's the max RPMs, and I've probably succeeded at that now. Looks like it's... Here, let me get you the windows that are easier to read. Well, that's weird, but okay. There we go. 57, 38, okay, and then the RPM. So 66. So 1700 for fan 3 is the max on both. And 6600 and 5000. All right. Done with that. I want to go back to normal fan mode. Okay, so both systems are on standard fan mode now. And now, let's see what happens. If I let them run like that for quite a while. It's getting a little late, I don't know, maybe half an hour, we'll see. So what's needed, we're done with watts, we know what that is, it's stable, not much to show you there anymore. So I'm going to get rid of that display. Let's maximize this, maximize that. And now, you can actually see dims too. I guess I'm just going to leave that screen. That'll be the before shot. One notch down. There we go. Now the two screens have a similar display, and you're going to see the clock in the bottom right, 9:44 p.m., jump to some later time, and any green bars moving significantly, meaning we've left steady state and things are still climbing as I talk here. Since moving the fan to since moving the fan to standard speeds, I've been talking for probably at least a minute and a half. And, I'm curious, how long does it take to other components just gradually creep up and get hotter, hotter, hotter when I leave it running for a long time? I don't know. That's a question I want to see. So I'm pausing the recording of the video now, and I'll be back in a bit, and we'll see which number jumps. So get ready to watch everything carefully, starting now. Okay, I'm back. It's around 10 p.m. now, and the numbers just budge very slightly. So I've also noticed in the past, taking the lid off, the cover off the chassis, not a big deal. The only thing it would affect would be you might get thermal throttling of the NVMe drive a little. That's about it. If you're talking about a Samsung 950 Pro being benchmarked for extensive periods, yeah, when you take the lid off, not the greatest idea for airflow. But as far as the motherboard components, they stand up quite well. I've actually run without a heatsink briefly. You get up to 95 Celsius and it still doesn't do thermal throttling, auto shut off. So these Xeon Ds are designed to run, easily handle high temperature. So I don't really see a reason for concern or to get all crazy worried about cooling, especially on the mini tower. All right, so we have the two jobs. I'm going to start them off at the same time, 10:38 p.m. here. And we'll see how it goes. So here we go. Yeah, this can be fun to check stuff. Watt burn I should have showed you before. It was at about 30 watts from a previous data. We know that's where idle is on this particular type of machine. But of course now it's cranked right up. Not to the maximum the machine is capable of. I showed with Prime 95 it was even worse. The abuse that happened back then. But it's cranking right along. And yes, there's a watt penalty for the more cores on the right. But we're also seeing it get more work done. So let's see how this looks. All right. So we've got the render job not showing. How about I move that over here? Well, it's a little sluggish because the machine is incredibly busy, right? Do the same thing here. And of course, I'm going to want to jump ahead in time to give you a look at, how does this look when it's further along. But already we're seeing quite a difference in performance. Now you might wonder, why would you use a server like this for a workstation workload? Well, this is just a compute heavy workload. I did a default install, and when there's no real GPU grunt or horsepower available locally, which is the case here, this is just a generic VGA driver we got here. I didn't even bother with the kind of Supermicro provided one. So I left it alone with a default install of Windows Server. And these machines were installed identically. Just Windows Server 2016, the GA version. Handy that came out in late November. Sorry, late October. All right, I think I'm done with showing you Device Manager. But yeah, that's it. It's going faster. And seems to be kind of linear. Meaning we might get to 10% here when we're at around 6.66% here. That would be linear scaling. A third more cores, jumping from 8 to 12. 4 more cores, which is half the original. So 8 plus 4 is 12, of course. Is it linear? Well, maybe not quite. But yes, you are getting something for your extra money here for the higher CPU. So moving from a 1541 to a 1567, we can pretty much guess how long the job is going to take based on extrapolating just the numbers from where we are to where it's going to finish. And it sure looks like the one on the right is going to finish about 25% quicker than the one on the left. And again, watt burn, we can see the penalty there. We are burning some more watts, but certainly not, 33 or 50% more. All right, so at this point, I'm probably just going to jump ahead in time till when the render job is almost done with the one on the right, and then almost done in the one on the left. Then I'll have this video wrapped up. So stand by, pausing now. Okay, we're cruising along here. We're almost done on the right. I forgot to show you this thing called SuperDoctor. That also shows you the component temperatures like CPU. I showed that earlier, and I decided to add this video or tack this on. This video rendering is going to be tacked onto the end of my Prime 95 abuse test. It's just a more, practical test. Okay, on the right, we're coming up on complete. On the left, I'm just trying to show you a utility that I had running earlier that shows fan speeds. So we can see fans on normal. I didn't go beyond the factory default. And temperature of CPU is not a big deal, 65 Celsius. All right, let's minimize that for a second. So earlier, simple math, 8 versus 12. So 8 is 2/3 the number of cores that 12 would be. So you might expect about a 33% difference between these two results. Instead, we're getting more like 100% versus 72%. So an 18% difference. So it did finish on the right, 100%. It's about to finish making an MP4 file. And that took, till 11 o'clock. Can't remember what the clock said when it started, but in post-production, that should be pretty obvious in the video. All right, and the one on the left obviously still has some time to go. So you're going to want to look at the clock difference, but it's pretty obvious. It finished at 11, or 11:01 actually, is when the job came up. So that should make it pretty easy to see when the one on the left is finished. All right. Also, that PC doctor business here, let's, open production file. Sure, why not? And we can do an embedded player and blah, 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 test that. All right, so that finished. Over here. So now we have real workload from, practical things someone might actually do with the server, just a video rendering farm kind of thing. And what we're seeing here is no big deal in the temperatures. The one on the right cooled right down because it's been done for a few minutes. So I did manage to miss, but earlier Prime 95 we know is even more abusive. I think it was 71 Celsius at worst. All right. So on the left, looks like another 5 minutes or so will be done. I'm going to pause the video until that's complete. Be right back. Okay, I'll need to go back and look at the clock. I think it was 1/4 of, wasn't it? Well, whatever. Took about 10 minutes longer for this next one to finish up. Now, a comment about this URL I showed you earlier, tinkertry.com/compare. You go there, and it brings you right to this table. Near the bottom, I'm going to double check all this. Notice I'm showing about under ESXi in a VM with Prime 95 versus running natively on Windows, and that was technical preview. So I got to update this, so stay tuned for updates. Either way, it seems whether we're under VMware or not, when under load, whether VM is running Prime 95 or something like this video rendering, the overall watt burn on the system seems to be similar, unless you have other VMs, of course, using watts too, but you can't go beyond the max, right? So we already found with Prime 95 running right on this Windows Server 2016 instance, we know the limits of the system. If we add a GPU in the PCI slot, okay, it'll go up a bit. Another 40, 50 watts. We won't get anywhere near the 250 watts of the power supply. All right, so just kind of closing out that bit of conversation. So 11:01 is when the last render job finished. This one looks like it's going to be something like 11:11. We're full 10 minutes later or so. So the other thing to point out is that this article, right in the home page here, October 27th, here we go. This article, I'm just going to add this video right to the bottom of it. So where I show the differences in the system, well, what a better way to highlight CPU, watt burn, and all that than to add a video that demonstrates, shows you everything you just saw for anyone else who's reading this article trying to find about the cooling solution and what changed with the new Xeon 12 core. So I think this is a pretty thorough view. Oh, okay. Yep, that's normal. It finished. And now it opens up a browser window trying to play the video back. And both systems settle right back to 36 watts idle. So Under Windows anyway, you don't get a watt penalty with more cores. Under VMware, I suspect we will, because I saw that in the past. I also have a foreign 6-core system that I've been using, but I have to return very soon. So this top column here shows you all the models and types we're talking about here and how many cores. So when we get over to VMware, there's this thing called cores times gigahertz CPU capacity. So today the highlighting was here, 16.8 versus 25.2. These two columns is what I was showing you. Okay, I think we're done. It's not going to play back video, I don't think, in a server operating system like this. So that's it. Hopefully you learned a few things along the way and found this video helpful. Thanks for watching. And thanks for visiting tinkertry.com.